Alright, so looking at today's lesson, it's going to be very simple. Basically, you have to identify a property of equality. Some of these you guys have heard of before, some of you may have not. And then we have to actually complete a proof. So we're actually, towards the end of the lesson today, we're going to start talking about proofs and what they look like. And I know right now some of you guys, your blood pressure is starting to rise, you're starting to freak out because now the word proof has been mentioned. And yes, we're moving into geometric proofs. And don't worry, okay? We're going to make it through this. Not a big deal. Believe it or not, guys, every time you do a problem set, you're effectively doing a proof. So you guys have done proofs before. All right, it's not anything to be afraid of. So let's move forward. And I'm going to call on some volunteers here. So we talk about algebraic properties of equality. It's something that you guys have seen before. You might not remember it, but you've seen it before. I think when I was looking through different textbooks, the earliest I've seen these starting to mention was the 6th grade math level. I started talking about distributive property and reflexive and symmetric. And so you guys have seen these before. So now I'm calling you guys to be good volunteers. Samuel, I want you to go up there and choose one of the 3 options there on the right and match it with the property on the left. Doesn't just go up there and do it. Just literally grab and pull. If it's wrong, try not to make fun of him for it.
Right there or up here?
Doesn't really matter. You're setting the tone, so you can do whatever you want. Okay, so reflexive. Guys, what does reflexive mean?
Like, if you were to reflect, like if you're graphing and you have like a shape, you want to reflect it across the y or the x-axis, like it'll be the same shape, it'll just be like the opposite. Like, I don't know how to explain it.
Yeah, it's really weird. Unfortunately, no, Sam, you're not correct on this one.
Okay.
But your reasoning is not far off. You are right. Reflexive typically is actually, and what I always tell people when you look in the mirror,
Yeah.
and that's a reflection of you, and what you see is what you get.
So D equals D.
So D equals D. Same thing on both sides. All right, so anytime we have the same thing on each side of that equation, that's sort of the reflexive property. Now, Sam, earlier you're talking about flipping it over the y-axis, right?
Yeah.
Or sending it off over the x-axis.
Yeah.
That's more symmetry,
Okay.
okay? And so, in that case, you were somewhat correct on that. If A equals B, then B equals A. So anytime we switch the order in which it's written, that's going to be the symmetric property.
Okay.
And then finally, it's the transitive property. And this one, here's the basic one I'm going to tell you. Reflexive property, how many equals do we have?
3,
We have 1 equals on reflexive. How many do we have for symmetric?
2.
2. And transitive, you're going to have 3. If A equals B, I want you guys to actually follow the logic on this. If A is equal to B, and B is equal to C, then A must equal C. And that's going to be the transitive property. It's very similar to a substitution. A lot of times it's going to be difficult to tell the difference between them. But if A is equal to B and B is equal to C, therefore A must equal C. Alright, any questions on this? Alright, then we have a couple others you guys maybe not have heard of before. The identities versus inverses. The identity is something that makes it stay the same. And we have an additive identity, and we have a multiplicative identity. What does the additive identity imply?
Addition.
Addition. What do you add to something to keep it the same?
0.
0, okay? So, and that means basically, anytime you're adding 0 to something, a plus 0 equals a. That's called the additive identity. If you're adding 0 to something and it stays the same, it's called the additive identity. So multiplicative identity, again, what does that imply? Multiplication. What do you multiply something by to keep it the same? 1. So therefore, a times 1 equals a. Hard stop. Now let's start talking about inverses. Before we talk about inverses, I want to go back to a very simple time in our lives. You know, the good old times. A plus 3 is equal to 5. Gosh, you still love these types of equations, right? You wish that this was the full extent of Algebra 1. Life would have been so much better.
Oh, yeah.
Now, how do we solve for A?
Subtract 3.
Why do you subtract 3?
So you blank times 3.
So, blank plus 3 is equal to 5. Do you guys realize, did you understand what we just said there? Blank plus 3 is equal to 5. Do you guys realize you guys have been doing algebra since like the 3rd grade? When you get those little worksheets that have a box, plus 2 is equal to 5. That was actually the concept of algebra.
Dun dun dun.
But anyways, the reason why I bring this up is you guys say to subtract 3. I want you to do one side, and do the other. But I want you to notice right here. Why do we subtract 3? Because what does it do to the positive 3? It cancels it out. So when we're canceling with addition, what are we canceling it to? 0. So an additive inverse is exactly that. It's when you get the outcome to be 0. So A plus negative A is 0. Therefore, A and negative A are additive inverses. Okay, so that's pretty simple, right? Let's do something similar. 3 times A equals 15.
Okay, so you divide by.
Divide by 3. Instead of dividing by 3, what can I multiply by?
Negative.
No. Come on, guys. Dividing by 3, when we talk about this before in this class, if you divide by a value, it's the same thing as multiplying by what?
It's reciprocal.
Right, it's reciprocal. So what's the reciprocal of 3?
1/3.
1/3. So what I'm going to do is multiply both sides by 1/3. Why do I want to multiply by 1/3? What does the 1/3 do to the 3? Cancels out. When again, we're talking about multiplying, we say things cancel out. What are we really getting them to cancel out to? No. You're going to cancel out to 1. So the multiplicative inverse is when you have a certain value multiplied by its reciprocal, and our outcome is 1. That's the multiplicative inverse. Okay, so a couple other properties we have in there. We have things like the addition property, which is if you add one thing to one side, you gotta add to the other. Then you got subtraction, you've got division, we've got multiplication, we got those big 4. But if you add, subtract, multiply, or divide to one side, you have to do the other. Then there's also the distributive property, which I'm going to assume most of you guys can recognize distributive. And then the last one is substitution property. And substitution can sometimes be a little bit confusing with transitive. You can almost use one in place of the other. Not always. We'll talk about that here in a minute. So the next slide. I'm really going to put you guys to the test. We have 4 examples. Four wonderful examples. Your task is to correctly identify those 4. Going up first is Morgan Vogel, number 1. If 5 is equal to 3x minus 4, then 3x minus 4 is equal to 5. So which property is that? I know, before you sit down, Morgan. Remember with reflexive property? Reflexive property is when it's the same exact thing on both sides. Okay, so which one is it when we switch the sides in which they're written, or the order in which they're written? Okay. Should be symmetric. Very good. Move that one out. All right, good job. All right, number 2. If angle 1 is equal to 90, and the measure of angle 2 is equal to 90, then the measure of angle 1 is equal to the measure of angle 2. So, Kiana, which property is that?
Hold on, I'm writing it down.
Okay.
I think symmetric, but that's already taken.
Yeah. What do you think it is, Courtney?
However you say that word.
Should be the transitive property. Courtney, why don't you go ahead and move that down? It should be transitive property. Remember, guys, transitive, it's basically when 2 things are equal to the same thing, then they are therefore equal to each other. When you have 2 things that are equal to the same thing, they are therefore equal to each other. When we look at number 2, angle 1 is equal to 90 and angle 2 is equal to 90, therefore they are equal to each other. Number 3. Question you might want to ask yourself on number 3 is what changed? What changed? So we look at number 3. If the measure of angle 1 plus 30 is 90, then the measure of angle 1 is equal to 60. So if the measure of angle 1 plus 30 is 90, then the measure of angle 1 is equal to 60. So a little bit of time to think on that one. All right, so they want you to go ahead and do number 3.
Is that right?
Yeah, that's right. Good job. All right, and finally, number 4. If 5x equals 15, then x is equal to 3. 5x equals 15, then x is equal to 3. Amber, why don't you go ahead and try that one? What did you do? You like deleted the entire notes. That's good. So yeah, division should have been the correct answer on that one. Seriously, what did you do? Oh, that's what we did. There we go. All right. So we're gonna take a break here.